Hello and good morning, everyone. I welcome you all to India's largest e-learning platform, Unacademy. And I welcome you all to the GATE Conqueror channel. And I welcome you all to my session, Special Problems on Capacitors and Inductors. Very, very important session because these are repeatedly asked problems on capacitors and inductors. So let us concentrate on how to solve these numericals related to capacitors and inductors. Just confirm the video and audio once. We'll move forward. Good. Is the video audio clear? Just let me know. Good one. So we'll move forward. Before we start the class, let me introduce myself. I'm GC Reddy. Secured AIR 1931. I work as motivation speaker, expert in EMFT, communications, advanced communications, microwave engineering, antennas and wave propagation, and digital circuits. These are areas of expertise. Yes, dear. Good morning. Nice, nice. We'll move ahead. This is our official Telegram channel for the GATE Conqueror team. You can access all the faculties of the GATE Conqueror team, including the legendary Kane browser, on this Telegram platform. Just make a note of this. Join us on Telegram so that you can interact with us more closer. Unacademy provides two paid platforms for us for learning. One is the Plus platform, where you got to have the FaceTime of legendary faculties in the form of live classes. We'll have weekly test. Practice is very important, so we have weekly test also. We have structured courses, so there won't be any ambiguity among the course. Exactly, it will be finished within the deadlines given to you in hand. You can have unlimited access. Once you get the subscription, you can join in any batch. There is no restriction that you should only join in this particular batches. So that's a very good advantage that we at Unacademy will provide. We have rank improvement batches. You need not pay separately again for rank improvement batches and all. All will be covered in Plus subscription only. And there will be crash courses every now and then. You can also join them. See, the level of learning or the way of learning will be different in a conventional long-term course, rank improvement batches and crash courses. These three levels of learning you can feel, experience within this plus subscription. Good morning, Anil. See, most of the people ask me this, why different batches? If you go for a long-term batch of a plus subscription, the teaching methodology will be different. We'll go in-depth theory. We'll teach in-depth theory here, all PYQs and practice questions. If you go for a rank improvement batch, we pre-assume that your theory is good. You want to improve your rank. You might have already solved your previous year questions. Theory is good. If you want to go for theory and PYQ, anyways with the plus subscription, you can go through the long-term course. But in rank improvement batch, we try to cover the untapped regions, important areas which are not covered previously, and lot of practice questions will give. The practice questions designed by India's topmost faculty. Now what it happens is, it improves your chances of getting a good rank, or it improves your chances of getting a top rank. Similarly, we have crash courses. For example, a long-term course of EMF may take 80 hours. We'll try to finish that in 20 hours in crash course. It acts as a revision for us. Those who want to revise these concepts 6 months before you had completed, example EMT, and you want to revise it further, you can go for crash course. See, all these advantages we have, and you need not pay separately for anything. Everything is covered in the plus subscription. Try to understand this. In iconic subscription, you got to have all the advantages of the plus subscription. Along with that, you'll also have a personal coach for one-on-one guidance and preparation strategies. So you'll have a personal coach. You'll try to monitor your SWOT analysis. You will do your SWOT analysis and you'll try to work on your weaknesses so that you get a very good rank. That's in iconic. And whenever you get a doubt, there will be dedicated doubt clearing educators for you. Your doubt will be cleared then and there. You need not wait for the doubt to be resolved for a long time. Maximum time in 24 hours will clear it off. Within a day, we'll clear your doubt, nothing to worry. And we have a customized study planner for you. As you know, each one of them, learning methodologies will be different. You cannot apply one's learning methodology to another. So we have different learning methodologies for everyone. For that, we try to prepare a customized study planner for you, and we'll also make you attend some regular workshops, study booster sessions. And also, after you write the test, we'll give you personalized test analysis so that you understand subject-wise and topic-wise your strengths and weakness, so that you can easily work on that. And also, we'll give you specialized notes and practice sets. So with all this feature, you are going to become very, very strong. That is for iconic subscription. If you're going for your plus subscription or iconic subscription, I recommend you to go for a no cost EMI. This is the best option that you have, because in no cost EMI, the total cost will be divided by number of months without any extra charges. For example, you want to go for 12-month plus subscription instead of paying 32,450 at a time. What you do is you try to pay 2,704. That is what you pay on monthly basis. This is after using my code GCR10. The same is applicable for Iconic subscription. Instead of paying 56,450, you pay 4,704 per month. This is after using the code GCR10. Is that clear? Yes. Everyone kindly respond. Is that clear? So we are into the full comprehensive course of EMF, where we have completed broadly the main topics I am writing here. Maxwell equations for static fields, we had completed Maxwell equations for static fields, where we had gone through Gauss law for electrostatic fields. That's Maxwell's first equation. Conservative property of electrostatic field, Maxwell's second equation. Ampere's law, Maxwell's third equation. Non-existence of magnetic monopole, also called as Gauss law for magnetic fields. That's Maxwell's fourth equation. This we had completed Maxwell equations broadly. Important points only I am trying to discuss, so that those who are newly joined our classes can go through them. Good morning, Bhaskar. Srikanth, good morning. And also we had completed Maxwell equations for time varying fields. In Maxwell equations for time varying fields, this first equation and the fourth equation are same, just like static fields. The second and third are going to change. The second equation that we change is from Faraday's law. And third equation that we changed is from Maxwell contribution, also called as inconsistency of Ampere's law. Hello, Ravindra. Hello, Bhaskar. You are asking some question, Bhaskar, the other day. You can please ask. We'll try to resolve it here, okay? Then we had seen completed Poisson's and Laplace equation. We had completed boundary conditions. And also we derived capacitors, capacitance of different kinds of capacitors, and inductance. Capacitance and inductance. Also we derived the capacitance and inductance. We had covered this fully and comprehensively, such that it will be useful for both GATE and engineering services. We have done so many number of practice questions, previous year questions, and also all the derivations. Almost we had solved it fully comprehensively, all these topics. Good morning, Rajdeep. In today's session, we'll see special problems on capacitors and inductors. Those who had missed out, go through this playlist here. Today is lecture number 39. This is turning out to be a wonderful playlist. I really like this playlist because this playlist is full and comprehensive. It will be useful for all the examinations. Kindly add the playlist to your playlist, to your customized playlist, so that it will be useful for you. So we know the capacitors and inductors, the capacitance of different kinds of capacitors we had seen in the previous classes. If you go for a parallel plate capacitor, the parallel plate capacitor having an area of A on each plate, separated by dielectric with epsilon, distance between them is D. The capacitance of the parallel plate capacitor is given by epsilon A by D. And if you consider a solenoid, inductance is N square mu A by D, where D is the length of the solenoid. D is the length of the solenoid. How are you, Rajdeep? And why I got this N square? Previous class I explained, am I right? In our previous class we had seen why we got this N square. Please refer to the derivation that we had completed in the previous class. If you consider a coaxial cable, the capacitance is 2 pi epsilon L by ln of B by A. And for this coaxial cable, the inductance is mu L by 2 pi into ln of B by A. We have derived all these derivations, not just the formula, but we have derived the derivations. Am I right? You can just go through them. If you consider a spherical capacitor, capacitance is given by 4 pi epsilon by 1 by A minus 1 by B. This also we have derived. And for an isolated sphere, B tends to infinity. For an isolated sphere of radius A, capacitance is 4 pi epsilon A. And if you consider a toroid, only this one we had not derived. It will be covered in engineering services. We'll derive this derivation also soon. The inductance is given by, if you consider a toroid, inductance is given by N square mu A by 2 pi R. N square mu A by 2 pi R. And here work done half CV square. Here work done half Li square. I is equal to C into dV by dt. V is equal to L into di by dt. Clear? You can call me anytime, Rajdeep, no problem. Just drop a message. Just drop a message in WhatsApp. You can call me anytime. Don't problem. That's not a problem at all, Rajdeep. I'll be very happy to help you out. Don't worry. Don't worry at all. Okay? No problem. Now we'll start doing problems on these capacitors. First one. A parallel plate capacitor shown in the figure. The figure was given in the exam. I'll draw it now. Parallel plate capacitor as shown in the figure has movable plates. These plates can be moved. The capacitor is charged so that the energy stored is E. Energy stored is E. When the separation is D, separation between the plates is D. The capacitance is then isolated electrically. Isolated electrically means the charge is not disturbed. Let the charge is Q. Isolated electrically, the charge won't be disturbed. And the plates are moved such that the plate separation is now 2D. If you are isolating the charges, the charge is not changed and the distance is doubled, automatically energy stored will also get doubled. That's the shortcut. Remember this shortcut. If the separation becomes 2D, at this new separation, energy stored as charge is not changing, separation got doubled, energy stored also will get doubled. And you need to neglect the fringing effects. The other day I told you what is fringing effects. If the capacitor plates are kept far away, then at the corners of the plate there will be non-uniform distribution of electric field. This phenomena of having non-uniform distribution around the plates of the capacitor is called fringing. Is it clear? So the shortcut is, if you have charge Q isolated and if the distance is getting doubled, energy stored will also get doubled. But you try to do it, this is the shortcut, but you try to do it with the procedure. Bhaskar, Rajdeep, Surendra, Srikant, Anil, try to apply the procedure. Try it out, dear. Done. You got the answer? What is the answer, Rajdeep? You got to E. E is electric, is the energy stored half CV square. C is Q by V. 1 by 2 QV. From this V is Q by C. Energy is Q square by 2C. Energy is Q square by 2C. So what you got? Energy is Q square by 2C. If E1 is Q1 square by 2C1, E2 is Q2 square by 2C2. But you know charges are not going to change isolated. This is Q square by 2C1 and Q square by 2C2. C1 The capacitance here for the parallel plate capacitor with distance d, epsilon naught A by D. C2 is epsilon naught A by 2D. Epsilon naught A by D by 2. That is C2 is C1 by 2. Substituting, this is Q square by 2, C1 by 2. 2 times of it. The new energy E2 is 2 times of Q square by 2 C1, energy E1, which is E. The new energy is, or the new energy stored is, very good. Super. I like it, Rajdeep. Good one. Is 2E. So nice, so nice, so nice. So nice. Okay. We'll go for the next problem. Generally, I teach Rajdeep in a detailed manner so that a student who is trying to listen for the first time also can catch up. Next, the capacitance of an air-filled parallel plate capacitor is 60 picofarad. The capacitance of an air-filled parallel plate capacitor is 60 picofarad. Air-filled parallel plate capacitor, epsilon naught A by D. A is the area of each plate, D is the distance between them. So given that epsilon naught A by D see, fringing will only, Bhaskar, fringing will only result in non-uniform distribution of electric field. For all practical consideration, the first and the foremost assumption is we consider that the field is uniform. Anyways, all this you are doing theoretically, no. Practically, you will have pattern recorder. Directly, you will get the value. But when you calculate theoretically, the value will be more. And why you are getting practically less value? Because of fringing. Because of the non-uniform distribution, the total electric field will decrease. That can be practically recorded by a pattern recorder. But you are doing it theoretically. Theoretically, you are trying to find the result here. Thank you, Rajdeep. Thank you so much. We'll move on. The capacitance is 60 picofarad, epsilon A by D. Now, the capacitance of an air-filled parallel plate capacitor is 60 picofarad. When the dielectric slab, whose thickness is half the distance between the plates, is placed on one of the plates, dielectric slab, whose thickness is half of the plates, whose thickness is equal to half of the distance between the plates, is placed on one of the plates. This is the thickness. The total distance between the plates is D. Thickness is half. So this is d by 2. This is also d by 2. Now clearly there are two capacitance here. This is C1. This is C2. How C1 and C2 are connected in series or parallel? Converting it entirely. Once this happens, the capacitance is converted entirely and the capacitance becomes 86 picofarad, neglecting the fringing effects. See here, dear, if you don't know about fringing, you'll think fringing will affect your calculated value. Theoretically, you will not have any effect. But wantedly, it will give you neglect the fringing effect so that a student with less theory knowledge will get confused here and will think there is some called fringing effect or correction factor that I don't know. Because of negative marking, this question will not be attempted by them. That's the ideology. That's it. Yes, Rajdev. The capacitors are in series. C equivalent is C1, C2 by C1 plus C2. So find the answer here. Start doing, find the answer. Given that the C equivalent, it is 86 picofarad. Find C1. C1 is epsilon A by D by 2. Epsilon naught. Epsilon R A by D by 2. 2 times of it. And C1 is 2 epsilon R of epsilon A by D. Epsilon A by D is 60 picofarad. 60 into 2, 120 epsilon R picofarad. C2 is epsilon naught A by D by 2. 2 times of epsilon naught A by D. 120 picofarad. C equivalent is C1 C2 by C1 plus C2. Find the answer. Find the answer. C1 you got, C2 you got. C equivalent is 86 picofarad. 86 is C1 120 epsilon R. C2 120 epsilon R plus 120. 86 is taking 120 common and cancel. 120 epsilon R by epsilon R plus 1. 86 epsilon R plus 86 is 120 epsilon R. 86 is 34 epsilon R. Epsilon R is 86 by 34. 2.53. That's your answer. Got it, everyone? Rajdeep, Bhaskar, Surendra. Got the answer? Any doubts? Clear? Okay. Next problem. A parallel plate capacitor has plates of 1500 centimeter square area separated by 5 mm. A parallel plate capacitor has plates of area 1500 centimeter square separated by 5 mm. Separated by 5 mm. Separated by 5 mm. Area 1500 centimeter square. Distance is 5 mm. If a layer of dielectric 2 mm thick and having a relative permittivity 3 is now introduced between the plates, a layer of dielectric 2 mm is now introduced between the plates. This is 2 mm is introduced between the plates. It is having an epsilon R of 3. Having an epsilon R of 3. Then the new separation in mm between the plates so that the capacitance value is unchanged. He's saying previously and now the capacitance value is unchanged. For this condition, find the new separation. How much is this separation? We don't know. This is 2 mm. This is we don't know. This we don't know. We need to find that separation. We don't know how much is this separation. Let be x. We need to find. The new separation is d new. Is x plus 2 mm. If I find this x, I'll get the new separation. But the condition is the capacitance value is not changing. Previously, how much is capacitance? C is epsilon naught A by D. D is 5 mm. Previously, the capacitance is epsilon naught A by 5. This capacitance won't change for this new combination also. Very clearly again, here it is C1, this is C2. How are C1 and C2? Tell me dear, in this case, how are C1 and C2? Are they in series or in parallel? How about C1 and C2? Are they in series or parallel? How they are? Let me know. Just like the previous question, these are in series. These are in series. So what do you get? C equivalent is C1 C2 by C1 plus C2. But you know, the resultant equivalent capacitance is C, which is epsilon naught A by 5. So find C1 and C2. C1 is epsilon naught epsilon R A by 2. Epsilon R is 3. C1 is 3 epsilon naught A by 2. C2 epsilon naught A by X. C epsilon naught A by 5 is C1 C2 3 epsilon naught A by 2 epsilon naught A by X by 3 epsilon naught A by 2 epsilon naught A by X plus epsilon naught A by X. Epsilon naught A by 5 is taking epsilon naught A by X common and cancel. 3 epsilon naught A by 2 by 1 plus epsilon naught A by X I took common. 1 plus 3x by 2. This implies epsilon naught A, if you cancel out, 1 by 5 is equal to 3 by 2 by 1 plus 3x by 2. 1 plus 3x by 2 is 15 by 2. 2 plus 3x is 15. 3x is 13. X is 4.333 mm. Therefore, the new separation is 2 plus 4.333, 6.333 mm. Is it clear? Just let me know. Is that clear, dear? Very important model of a problem. Very important model. Kindly make a note. Next one. A 3 microfarad capacitor is charged by constant current of 2 microampere for 6 seconds. Voltage across the capacitor to the end of charging will be dash volt. Solve it, dear. Good question, Rajdeep. But area is not having any effect. They are getting cancelled out. In our question, area has nothing to do because you are cancelling it out now. You write in mm also, will cancel it out. That's why I had not substituted A at all. In calculation, I had not substituted A because anyways I'll cancel out A. See, is there any effect of A here? A is just cancelled out. Whatever A you write here, it does not matter. That's why there is no effect. Otherwise, you need to convert. That's the reason why I had not substituted the value of A also. Clear? Yes, try to find this. I is equal to C into dV by dt. I is 2 micro, capacitance 3 micro into dV by dt. 2 by 3 is dV by dt. Applying integral on both sides. 2 by 3t is equal to V. T is 6 seconds. V is 2 by 3 into 6. V is 4 volts. Your answer will be 4 volts. Clear? Next question. A point charge of plus 10 microcoulomb is placed at a distance of 5 centimeter from the center of a conducting ground sphere of radius 2 centimeter is shown in the figure. What is the total induced charge on the conducting sphere? How to find? C is equal to Q by V. Q is induced charge, Q in. I want Q in. Q in is equal to C into V. C is the capacitance of this isolated sphere. What is the capacitance of the isolated sphere? 4 pi epsilon A, where A is the radius of the isolated sphere, which is 2 centimeter here. Here A is 2 centimeter. Capacitance is 4 pi epsilon A. Free space is there, epsilon naught. 4 pi epsilon naught A. And V is potential Q by 4 pi epsilon naught R. Q is 10 microcoulomb given here. Ten into 10 power minus 6 by 4 pi epsilon naught R, where R is the radius, which is 5 centimeter. V is 10 micro by 4 pi epsilon naught R. 4 pi epsilon naught get cancelled. A is 2 centimeter, 2 into 10 power minus 2. Q is 10 micro, 10 into 10 power minus 6. By R is 5 centimeter. 5 into 10 power minus 2. They cancel out. 20 by 5. 4 into 10 power minus 6. 4 microcoulomb. Out of 10 microcoulomb, 4 microcoulomb is induced into this charge, into this sphere. Out of 10 microcoulomb, 4 microcoulomb is been induced into the sphere. Yes, yes. 4 micro. Is it clear? Next one. The space between the plates of a parallel plate capacitor of capacitance C, the space between the plates of a parallel plate capacitor, capacitance of a parallel plate capacitor, epsilon naught A by D, is filled with 3 dielectrics now, 3 dielectric slabs of identical size as shown in the figure. This figure is given. The dielectric constants are epsilon 1, epsilon 2 and epsilon 3. The new capacitance is C new. Tell me how are they connected? Epsilon 1 will have C1, epsilon 2 will have C2, epsilon 3 will have C3. How are C1, C2, C3 connected? How are C1, C2, C3 connected? Are they in series or parallel? Bhaskar, Rajdeep, anyone? Can you tell me how they are? Are they in series or in parallel? How they are connected? Very clearly, C1, C2, C3 are in parallel. C new is C1 plus C2 plus C3. What is C1? Epsilon 1. Area is divided to 3, A by 3 by D. Is epsilon naught, epsilon R1, A by 3D. C2, same epsilon 2, A by 3 by D. Epsilon naught, epsilon R2 into A by 3D. C3 same epsilon 3 A by 3 by D. Epsilon naught, epsilon R3 A by 3D. Says epsilon naught A by 3D, epsilon R1 plus epsilon R2 plus epsilon R3. Epsilon naught A by D is C. This is C by 3 of epsilon R1 plus epsilon R2 plus epsilon R3. That's your answer. Parallel. Very good. Very good, Bhaskar. Good one. Is that clear? Do you all got the same answer? Next one. A coaxial cable or coaxial cylindrical capacitor shown in figure A as a dielectric with relative permittivity epsilon R1 is equal to 2. This figure A, let us analyze this figure A first. Cylindrical capacitor, the capacitance of a cylindrical capacitor or coaxial cable C1 is 2 pi epsilon L ln of B by A. Here B is capital R, A is small r. C1 is 2 pi epsilon naught epsilon R1. Let it be epsilon 1. Epsilon R1 L by ln of R by R. Given epsilon R1 is 2. Substituting C1 is 4 pi epsilon naught L by ln of R by R. Now, when 1/4 portion of the dielectric, is now replaced with another dielectric of relative permittivity epsilon R2 as shown in figure B, the capacitance is doubled. Let the capacitance is C2, which became 2 times of C1. So C2 became 8 pi epsilon naught L by ln of R by R. C2 became 8 pi epsilon naught L by ln of R by R. Capacitance is doubled. We have noted down. The value of epsilon R2 is, I want this value. I want the value of this epsilon R2. Now here very clearly there are two capacitors C3, C4. How are C3 and C4 connected? Anyone? Here, how are C3 and C4 connected? I have a question regarding capacitor. Please ask. Sai, how to identify this coaxial cable in series or parallel? Good question. Good question. Good question. I really like this question. I'll give explanation. Don't worry. And Bhaskar, any doubt? Someone with name T. I have a question regarding capacitor. Please ask, dear. Please ask. Sai, kindly give me 2 more minutes. I will definitely clear your doubt. Okay. Bhaskar, any doubts? Ask me first. Then, what is your doubt, dear? With name T. You can also ask. Then I'll clear off the doubt by Sai also. Ask, dear. Capacitor will store the energy based on the voltage applied only, no? Only when there is a potential difference between the plates, electric field will move from one plate to another. The electric field that and thereby is stored between the plates. That's why it is based on voltage. Whereas magnetic field is because of the current passing through the inductor. That's why the inductance or the inductor is based on current. Capacitor based on voltage. Only when I apply potential difference, then you'll have the change in potential, because of which electric field will move from higher potential to lower potential. Clear? Next. Someone with name T. What is your doubt regarding capacitor here? Please ask. Then we'll go for doubt by Sai. Sai, you there? Bhaskar, is it clear? Okay, dear. Someone with name T is supposed to ask it out. Whenever you ask the doubt, I'll clear it out. Don't worry. We'll clear off Sai doubt. What is your doubt, Sai? How to identify these coaxial cables in series or parallel? Okay. Sai, are you present? I'll clear your doubt, Sai. Don't worry. This is a parallel plate capacitor. A dielectric is placed something like this. Dielectric constant epsilon r. This is representing C1. This is representing C2. How they are connected? Everyone, how they are connected? Tell me. Capacitor won't store DC here. It blocks DC. It blocks DC. You tell me the connection here. Is it series or parallel? This is series. C equivalent is C1 C2 by C1 plus C2. Now you tell me. Now you tell me. Now how is the connection? Series or parallel? Series or parallel? Parallel. How to identify? Plates will be same. Plates will be same. Plates are different. Plus minus, plus minus. The plates are common, parallel. Plates are different, series. Here C equivalent, C1 plus C2 plus C3. Got it? Series, parallel. Now, Sai, are you present? You there, dear? Now, what was your doubt? How to identify these coaxial cables in series or parallel? I explained you parallel plate. I'll explain you coaxial cable. One coaxial cable. There's one more coaxial cable. Okay. Now, if you are filling with dielectric, like this, this connection is series or parallel. This is parallel. This is parallel. Now, if you have like this, now you tell me, series or parallel? Series. How to identify? Anyone? Bhaskar, Rajdeep, Sai. How to identify? Any idea or shall I explain? Please respond. Can you identify or shall I tell you the technique? Rajdeep, can you tell me any technique? Sai, take a knife. Take a knife and cut this. Take a knife and cut this cable here. Cut this cable here. Now make this straight. What you got? You'll get this. Cut the cable there and make it straight. What you got? You'll get this parallel. Take a knife and cut it here and make it straight. What you got? This series. Now there must not be any problem at all. They both are same. What was the previous problem? The problem we are doing now, this thing. That's why parallel. That's why parallel. Okay. This is this connection. That's why parallel. Now, C3, C4 are there. C3 and C4 are in parallel. C3 and C4 are in parallel. Find C3, find C4. Parallel connection, you get the answer. How much is C3? How much is occupied? 1/4. What is the capacitance formula for coaxial cable? 2 pi epsilon L by ln of B by A. When is this applicable? For complete capacitor, 2 pi. Now only 1/4 is there. 1/4 of 2 pi. Pi by 2. Replace 2 pi by pi by 2. Epsilon L by ln of B by A. C4. 3/4 time. 3/4 time of 2 pi. 3 pi by 2. Replace 2 pi by 3 pi by 2. This point is very important. 3 pi by 2 epsilon L by ln of B by A. C3 epsilon is epsilon R2. So epsilon naught into epsilon naught into epsilon R2. This is epsilon naught into epsilon R1. They both are in parallel. Therefore, C2 is equal to C3 plus C4. Epsilon R2 is 2. Substitute pi by 2 into epsilon naught L. Epsilon R2 2 by ln of B by A, R by R. Sorry, epsilon R2. Epsilon R2 you need to find. Epsilon R2 you need to find. Keep it as it is. This one 3 pi by 2 epsilon naught L epsilon R1 is 2. Is 2 by ln of R by R. C2 is C3 plus C4. If you take pi epsilon naught L by ln of R by R common here, pi epsilon naught L by ln of R by R common, what is left out? Epsilon R2 by 2 plus pi epsilon naught L by ln of R by R, if you take common, plus 3 is equal to C2, which is 8 times pi epsilon naught L by ln of R by R. They get cancelled. Epsilon R2 by 3 plus 3 is equal to 8. Sorry. Epsilon R2 by 2 plus 3 is equal to 8. Epsilon R2 by 2 is 5. Epsilon R2 is 10. Is that clear? Is it clear? Next one. C naught is the capacitance of a parallel plate capacitor with air as dielectric, as in figure A. Capacitance is C naught, epsilon naught A by D, as in figure A. If half of the entire gap, as shown in figure B, is filled with dielectric permittivity epsilon R, the expression is modified to. Now you tell me in figure B what is the connection? Series or parallel? Series or parallel? What connection is employed? Is it series connection or parallel connection? Anyone? Find out. Tell me, dear. Is it series or parallel? Very clearly, it is again a parallel connection, common plates. So, C equivalent modified capacitance is C1 plus C2. C1 is epsilon naught. How much is area now? Area is divided. Distance is same. Area is half A by 2 by D plus epsilon A by 2 by D. Epsilon naught A by 2D plus epsilon naught epsilon R A by 2D. C equivalent is epsilon naught A by 2D into 1 plus epsilon R. Epsilon naught A by D is C naught. Epsilon naught A by 2D is C naught by 2 into 1 plus epsilon R. C equivalent is C naught by 2 into 1 plus epsilon R. C naught by 2 into 1 plus epsilon R. Option A is the answer. Clear? Last problem on this. The last problem on this. A parallel plate capacitor consisting two dielectric materials is shown in the figure. The middle dielectric slab is placed symmetrically with respect to two plates. If the potential difference between one of the plates and the nearest surface of dielectric interface is 2 volts, then ratio epsilon 1 is to epsilon 2 is dash. What is given? A parallel plate capacitor consisting of two dielectric materials shown in the figure. The middle dielectric slab is placed symmetrically, means covering half of the region. With respect to the plates, the potential difference between one of the plates and the nearest surface is 2 volt. That means how much is here? Here the applied voltage is 10 volt. Here 0 volt. The potential difference between one of the plates and the nearest surface is 2 volts. So here the potential difference, here the potential must be 8 volt. 8 volt. Here 0. The potential difference between the plates and the nearest surface is 2 volt. So here it must be 2 volt. So this is capacitor C1. The middle one is C2. The middle one is C2. So what is capacitance? Voltage across the capacitor C2. Voltage across capacitor C2 is total voltage into opposite capacitance by total capacitance. But C1 is epsilon 1. A is area by D, distance. Distance is same. Area is also same. C2 is epsilon 2 A by D. Why? Because you can redraw this as like this. And move this C2 to one corner. This is D1, this is D2. Both D1, D2, both are same. Area is same. Only thing that is changing is epsilon 1, epsilon 2. That's it. This is the equivalent. Therefore, in C1 and C2, only epsilons are changing. So, in this case, I can write it as epsilon 1 by epsilon 1 plus epsilon 2. Voltage across capacitor 2. Voltage across capacitor 2 is 8 volt minus 2 volt. 6 is equal to total voltage 10 epsilon 1 by epsilon 1 plus epsilon 2. This is 6 epsilon 1 plus 6 epsilon 2 is 10 epsilon 1. 6 epsilon 2 is equal to 4 epsilon 1. Implies epsilon 1 by epsilon 2 is 6 by 4 or 3 by 2. Ratio is 3:2. Ratio is 3:2. Option C is the answer. Is it clear? With iconic subscription, you'll get 1:1 mentoring, increasing your chances of getting a top rank. Use my code GCR10 to avail extra 10% off. With every 3-month subscription, they're giving away 1 month subscription for free. That means you can get 4-month subscription now. In this 4-month subscription, you can prepare for GATE 2022 and ESE 2022, because most of you are already on a go for GATE and ESE 2022. Now taking this small subscription for 4 months. Remember, only subscription is for 4 months, but you'll get access to all the videos for this 4 months. So you can quickly revise from India's topmost faculty in this 4 months, increasing your chances of getting a top rank in GATE and ESE. Good thing is we are giving you 1 month extra validity, and also if you are using my code GCR10, you'll get extra 10% off also. That means a subscription which is worth of 19,000. You'll get it for 13,000 and you will start your revision. Is that clear? There's also one more offer. With every 12-month subscription, we're giving away extra 3-month subscription. That means we'll give you 15-month subscription now, in which you can prepare for GATE and ESE 2022 and GATE and ESE 2023. And also this 15-month subscription you can utilize for preparing any other competitive exams that are occurring in between. What you actually pay is approximately 29,000. What it is worth is 47,000. You can save around 38% here. You will pay only 29,205 after you are using my code GCR10. You will save up almost 17,995. And the good thing is you can prepare up to GATE and ESE 2023. That's the advantage you'll have. This is also a very good offer. Those who are targeting GATE 2023, it's a very good offer here. Try to utilize it. And if there is any financial problem, you can also go for Unacademy Combat. Not only those who are having financial problem, but also for those who want to test their metal, test their knowledge, can also attempt this GATE and ESE Mega Combat tomorrow at 11 a.m. This, as you know, Unacademy Combat is a live quiz competition where 20 questions will be asked. 60 minutes will be given. These 20 questions will be curated by India's topmost faculty. And this quiz is for mechanical, civil, ECE, electrical and CSIT. This is for India's topmost faculty. This is designed by topmost faculty. So you can easily test your metal. And we are ready to give away scholarship worth of 4 crores for top 200 rankers. The first, second and third rankers will get a free subscription, 100% scholarship. 4 to 10 will get 75% scholarship. 11 to 50 will get 50% scholarship. 51 to 100 will get 25% scholarship. 101 to 200 will get 15% scholarship. If you are good at studies, then test your metal. Enroll it right away. After this class, you can enroll for the combat right away by using the code GCR10. Use the code GCR10 and enroll right away. Not only that, lucky 500 participants, just you participate irrespective of your scoring, will get chance to win all this gift that are mentioned here. So try to test your luck also there, and very all the best for this particular combat. This is going to be very, very important. It's a very important combat here. Try to concentrate and try to attempt this combat. You can use my code GCR10 to unlock this free initiative. In special classes, you'll be having interactive live classes, polls for the learners. Polls are very interesting and effective method of learning. You have raise hand option, not to interact with more enthusiasm with the educator. And once you follow the profile, you'll never miss a class because we'll send you customized notification for you. And after the class, you can download your lecture notes. You can access it anytime and anywhere. Unacademy has recently introduced a feature called Ask a Doubt, where you can ask unlimited number of doubts and get them clarified on our same platform. So you need not wander here and there to clear your doubts, dear. We'll take the responsibility of clearance of your doubt within 24 hours. What you need to do is just post the doubt. What you need to do is just post the doubt. These are the new batches, Arrow 1, GATE and ESE 2023. GATE and ESE 2023 aspirants for ECE, explained bilingual, started on 17th of November. Arrow 1, GATE and ESE 2023 for electrical, explained bilingual, started 17th of November. You can use my code GCR10 to avail extra 10% off. These are the new batches, GATE and ESE 2023 across the different branches, started on 17th of November. And this is modules for GATE and ESE 2022. In modules, we try to concentrate on some specific subjects. This has started on 24th of November for electrical, explained bilingual. These are modules for GATE and ESE, targeting GATE and ESE 2022 for ECE, explained bilingual, concentrating on specific subjects, started on 24th of November. And these are the different batches like verb, Arohan, modules and rank improvement batches for different branches. All of them started on 24th of November. And you can use my code GCR10 to avail extra 10% off. And this is where you can follow me on Unacademy app. Take a screenshot of this and share among your friends so that your friends can also follow us for a good learning experience there. Thank you all, dear. Thank you all from Team Unacademy. Thank you all from Team GATE Conqueror. And thank you from our leader, K.N. Ravsa. And thank you from me for your patience listening. And on behalf of the GATE Conqueror team, I'd like to give you a word that we people will stay with you for your preparation always. So you can trust on us. You can follow us on Telegram channel. You can follow us on this GATE Conqueror YouTube channel. You can follow us on special classes. We are very happy. We'll be very happy to be part of your success story. We'll be always ready to help. And we are here for all those who want to listen in English, especially South Indian people who want to listen their lectures in English. We are here because this is the English speaking channel. We are here for you. We are here for the entire India who want to listen classes in English. We'll stand for you. We'll stand for your success. Thank you all, dear.